Hello, everyone. Thank you for taking the time to attend our webinar. We are really excited to show you our platform and believe that you'll be pretty surprised at how we've addressed all the challenges that you've heard about with respect to generative AI right now. I'm going to start off introducing our two speakers. With me are Ryan Welsh, our CEO and founder, and Mark Oney, our Chief Product Officer. Just some housekeeping notes. Everyone will be muted during the presentation except for the speakers. You can submit questions via the Q&A button at any time during the webinar. Chat is disabled. We will address the questions after the presentation. If we don't have time to get to all of your questions, we will respond after the webinar. This webinar is being recorded and everyone will receive the recording post-webinar. Please feel free to share the recording with your colleagues. And to get started, I'm going to start with a quick poll to gauge where the audience stands now with respect to generative AI. Please just take 20 seconds to answer the two questions. You may have to scroll down. So hopefully you'll see the poll there. Again, please take 20 seconds, respond, and we'll see where people are at. All righty, let's see what we got. So it looks like that the primary concerns with generative AI, the highest is hallucinations. I guess that's not shocking to me. Losing control of data to external LLM models, also not shocking. And then, a smaller number think that it's time-consuming model training and fine-tuning and optimization, which are painful. And then it looks like everyone is actively assessing right now. No one has piloted or deployed yet, so our timing is good. Oh, I guess I could have shared results so you could see it. But all right, so with that, I will hand it off to Ryan to get started.
Perfect. Thank you, John. So the agenda for today, what we'll cover, we'll introduce our generative AI answer engine. We'll talk about the differentiation between our answer engine and some alternatives that people are building out there. Then we have a really great demo for everyone today to just kind of show you how these answer engines can optimize enterprise search. And so I'm sure everyone on the call is familiar with the high cost of bad search in the enterprise. For internal stakeholders, the most credible research that I've seen is that employees spend about 20% of their time looking for information. I know I spend a lot of time looking for information. And obviously that equates to about 1 day a week in lost productivity. And so just via bad search results, the inability for machines to really understand human language, we're stuck digging through these digital troves of information to find our answers. For external stakeholders, we're seeing a demand for the ability to self-serve, whether that's via chatbot or some other search interface. And these negative experiences that you have with chatbots can drive away a good percentage of customers. And for folks that come to your site for B2B buyers, we're seeing that about 50% of them create their buyer list based on the available information on a vendor's site. So they'll never reach out to speak with a sales rep or an SDR or anyone at the organization before they create that short list. And so obviously, if they can't find the answers to their questions out there on the web or on your site, you won't be on their short list of buyers. And so what we've built here at Kyndi is a generative AI answer engine. And so it is an enterprise-grade end-to-end solution, leveraging all the state-of-the-art technology available today. And it provides users with direct, accurate, and trustworthy answers directly to their questions. And so let's dive into each of those. And so gone are the days of asking keywords getting a result list back that is filled with mostly irrelevant documents that you then scroll and click through to find your answer. And so with answer engines, we're quite literally talking about getting direct answers to your questions. And so I like to say that, search engines have dominated for the last 50, 60 years. I think that era is now over. It probably ended with the release of ChatGPT, where users now understand that they can ask direct questions and get direct answers. Now, with the Kyndi answer engine, what is unique is that we're delivering contextually relevant and trustworthy answers. And so our results that we generate to user questions are always grounded in enterprise data, and there are no hallucinations. And we'll actually walk you through, how we ultimately do that. And uniquely today, when we talk about an answer engine, we're talking about a complete solution. I like to joke and say that, when you want to buy a search engine, do you go buy the tokenizer, the index, the UI, or do you go buy a search engine? You go buy a search engine. And so if you want to build an answer engine today, it turns out you got to buy all the individual components and have your teams build and manage and maintain that entire thing. Well, what we've done here at Kyndi is we've bundled all that together into a complete solution in an easy to use way. And so when we actually look at this architecture, and candidly, this is the common architecture that a lot of vendors are going to use, there will be different components under the hood, but this is kind of that standard architecture. You're going to see an embedding model, and we'll actually cover each of these components in subsequent slides. You'll then store the outputs of that embedding model into a vector store. Could be a vector database. At Kyndi here, we have a proprietary engine that we call cognitive memory. It's a storage and retrieval mechanism. And then ultimately, when you query that storage and retrieval mechanism and you get results out, you're going to push that back into a generative model to synthesize the single best answer to the user's question. And so, some of you may be looking at this architecture and say that the LLM can actually do is in two spots, and that is true. And so LLMs can do a lot of NLP tasks. And so you'll actually be using them in multiple spots, even though that technically could actually be the same large language model. And so when we talk about embeddings, some of you may be familiar with what embeddings are, but we're talking about numerical representation that enables semantic understanding and captures context-specific information. And so you may have built taxonomies, ontologies, these kind of human curated representations. What we're now talking about with vector embeddings is just a way for the computer to generate these numerical representations from the text data or from any data itself. And so you're not creating these human curated representations. You're enabling the machine to actually create these representations and capture those semantics and capture that context specific information. This obviously improves search recommendations and clustering of documents, because you now see the similarities across sentences, documents, paragraphs, groups of documents. And so this embedding step in that architecture is just for capturing all that semantic understanding and context specific information. The next step in the answer engine process is going to be this storage and retrieval mechanism that I was talking about. At Kyndi, we've built a highly differentiated storage and retrieval mechanism that we call cognitive memory. You can think about it as a vector and a graph representation. And if this is getting a little technical for folks, don't worry, we got use cases coming up here in a slide or two. And so with the cognitive memory, you get the best of a vector database. But unlike a vector database where you're maybe storing vectors at the document level and you're returning documents, we're storing at a much more granular level. This allows us to bring back highly specific sentences from the underlying documents that answers a user's question. By also leveraging a graph representation, we can actually capture a bunch of semantic and contextual information that cannot be captured in vectors. And so there's actually a limit to the amount of semantics that you can capture in a vector. What this graph representation also enables is knowledge management professionals to be able to adjust the representation and put human curated knowledge into that representation. And so this really gives knowledge management professionals control over the storage and retrieval mechanism. Whereas if you were just using pure vectors, you wouldn't have control over that. You'd ultimately be outsourcing that to your data science team. And by combining these two approaches, you have a system that quickly understands domain and industry specific terms and phrases, concepts and other things. And it provides explainability in the results. And so we're able to show you which words and which sentences are actually being used to generate the answer to the user's question. And now moving from that storage and retrieval mechanism onto the kind of the last step of an answer engine, it's now generating the answer. And so once you get some documents or some sentences out of your storage and retrieval, you're ultimately going to put them into a generative pre-trained transformer model to generate a single best answer. And so at Kyndi, we can leverage any third-party model. This is a part of the stack that isn't proprietary to us. There are no security issues. We can use private models, enable folks to control all of that information so that it's not flowing to some third-party vendor. The answers that we're ultimately summarizing are from that trusted enterprise content. And so because you're not relying solely on the large language model to generate the content, you're actually providing it a very small subset of information and asking it to synthesize the answer out of that information. The answer is rooted and grounded to the enterprise content. And so there are no hallucinations, and there's actually some tricks that you need to do and some software that you need to build to do some adversarial testing to ensure that. And ultimately, we've built that here at Kyndi, which is part of that complete solution that we talk about. And so because our storage and retrieval mechanism is very good at finding the very specific sentences in the underlying documents that answer the user's question, unlike other systems, we're putting a very small subset of information into a large language model to then have it be synthesized into the single best answer. And so because you're putting a small subset of information in, you get very high quality answers out and very low probability of hallucination. And so you're only getting a small subset of that highly relevant results to generate that answer, ultimately leading to highly accurate results. And we show all of the sources of that generative summary. And so this is another component of that storage and retrieval mechanism where you're able to actually go back to the underlying words and sentences in the underlying documents that were used to generate the answer. So end users, if they get an answer, they're thinking it sounds a little bit off, they can click on the answer and ultimately go back to the underlying documentation to confirm for themselves that the answer is correct. So this is just complete trusted results for the end user. So there's a few use cases that we've seen the biggest adoption in, and candidly, this is what a lot of folks are seeing, just where the question answering has the highest impact. As you can imagine, self-service customer support. So just providing customers with the right answers instantly. So the ability to ask information or ask questions of digital information and get those answers directly is a high value use case. And then even internally for self-service agent support. And so say there's questions that couldn't be answered by external stakeholders, you can empower internal stakeholders like your self-service agents to be able to ask sophisticated questions and get really direct answers to their questions internally, which then helps the external stakeholders. Then just really knowledge management for internal employees. And so this just completely changes the game of how employees find answers to questions. And so just the ability to ask questions of enterprise knowledge repositories and get very direct, contextually relevant and accurate answers just boosts the productivity of employees across the organization. And so with that, we'll actually get into a really cool demo for you, and I'll throw it over to Mark.
Okay, thanks, Ryan. Can you see my screen okay?
Yes.
Okay. So today I'll be demoing the powerful generative AI capabilities that are part of our Kyndi answer engine. I'm going to showcase 3 specific examples using a self-service use case, and this is built using content from E-Trade's public site for our demo. When we talk about the Kyndi Clarity engine, it's a natural language and generative AI powered self-service product, and it's built on top of our best-in-class natural language platform. In this example of customer self-service, with the website visitors to the E-Trade website, Kyndi's answer engine is providing 3 key benefits that I'll talk about today. First, our natural language enabled analytics allow you to align your content with the needs of your customers' needs. I'm going to show you some no-code tools that your brand management team can use in order to build out content. Secondly, we're going to show you our natural language analytics. Those allow you to align your content with the needs of your customer base. So you're able to draw a direct line between the questions and the topics that are top of mind for your customers with the quality and coverage of your support content, using the quality and relevance of the answers that we're serving up as a proxy. So I'll show you how that works. And finally, with the right content in your knowledge base, we make it really easy for your end users, your customers, to be able to find and consume the answers that they're looking for. So in terms of generative AI, I'll demonstrate 3 things today. First, building out a knowledge base in a matter of minutes based upon your content. Secondly, delivering accurate answers on the fly, whether those answers come from the knowledge base or we're leveraging generative AI to be able to derive concise and relevant answers from your content. And then finally, making it really easy for end users to consume that content easily and adding it to the knowledge base. For this demo, we ingested about 20 or so web pages worth of content from the E-Trade site. We created a knowledge base leveraging generative AI for our knowledge base or hub, and we added domain-specific terminology using some no-code, low-code tools that make it very easy to extend our language model for different use cases. So with that, let's jump right in. What I'm showing you here is an end user interface. This is an example of what I'll refer to as a widget. You could embed the Kyndi Clarity search bar within your header or your nav bar. And when an end user executes a query, they're going to be directed to this results page for our answer engine. So in this case, you can see that I asked a query, what are alternate investments and how do they help diversify a portfolio? Right up on top, you see an answer to that question shown prominently on top. What we've done here is we've taken this end user query, we've found a matching question within the knowledge base. In this case, it's a verbatim match. There's an answer that was auto-generated that is paired with this question. You can see here a label says verified result. That implies that we were using generative AI in order to auto-generate a question from your content for this particular question. When we talk about explainability, we make it very easy for people to really evaluate where the answer came from. So in this case, what you'll see is when I expand the view sources, these are the natural language search results that we found for this particular query when we're searching against all of that content that we ingested from the E-Trade website. And we're returning passages or snippets of relevant content. You can see certain words highlighted in blue that signify the connections between different words or tokens within the query and related information we find in content. Kyndi uses well over a dozen different novel natural language techniques and strategies in order to make those connections. So in contrast to token search, we're able to cast a much broader net to make many more connections between the end user's query and your content. This content is then fed to our generative AI in order to auto-generate this summarization. So you're not going out on the broader internet. We're not leveraging LLMs to do knowledge discovery out on the broader internet. This, as Ryan mentioned, is really confined and constrained only to your content. In addition, I can click through on any of these links within the results set, and you can see that it navigates me directly to the web page or a specific page of a specific document, so that I can make my own judgment contextually. Is this really the information I was looking for? So that level of explainability, of understanding the sources that went into our auto-generated summary and being able to click through on any of those sources, allows your end users to really have trust and confidence in the information you're returning, so they can act upon that information with confidence. Lastly, on the bottom, you see a section called People Also Ask. So in addition to doing a semantic comparison of the end user query to this top question, we're looking at other questions within the knowledge base that may have some thematic relevance to the question being asked. So in this case, you can see we're also surfacing information about alternate investments for diversification, or how futures can help to diversify a portfolio, or ways to protect your stock portfolio from downside risk. And we can click through on any of these results as well and pull back relevant information from the knowledge base. So next, let's ask a different question. I'm going to ask using margin for futures contracts. And what you'll see here is our intelligent type ahead. So unlike most term-based search products that are just doing a type ahead based upon matching of individual tokens, we're actually comparing the end user query semantically to different questions that are available within the knowledge base. And one of the benefits of that is, very often, if someone's accustomed to doing token searches, maybe 2 or 3 tokens, it's really hard to determine the context of what they're looking for. In this case, we tease them with knowledge that questions that are available within the knowledge base. So in this case, if I'm looking at using margin for futures contracts, this first question, how can I find the initial margin required for a futures contract? I can click on that, and it's going to pull up an answer to my question. Again, this was an auto-generated summary that was cached within the knowledge base. But what happens if someone comes in and asks a question for which there really isn't a good match within the knowledge base? Here I'm asking about risks associated with margin trading. It's talking about benefits, it's talking about how they work, but I'm going to go ahead and execute this query. And what you'll see for demo purposes is a little label here that says results not yet verified. What that's indicating is that this answer that I've served up, which again, I can view the sources and click through to ensure that this is really a good answer to my question, didn't yet exist in the knowledge base. So we've done an on-the-fly auto generation of a summary, again, grounded in this case, the 20 or so web pages that we ingested from the E-Trade website, in order to serve up an answer to this question. A little later in the demo, we'll look at then how easy it is to identify those questions that maybe are new areas of interest coming from your customer base, identifying those using a no-code curator tool to augment the knowledge base in order to add that question, so that the next time someone comes in and asks this question or a similar question, they're going to be able to serve up an answer like this that has been vetted by your support team or your content team in order to deliver the information that they're looking for. And then finally, I'm going to ask about opening a rollover IRA account. This talks about the process of opening a retirement account. I'm going to click on that. In this case, I'm showing you a curated result. Curated result gives you a little bit more control over the answer that's being served up. So it might have its genesis in an auto-generated summary, but perhaps you want to do a little bit more control over the wording, the formatting. You want to embed some links within the answer. This curation process allows you to have full control over those questions where you want to be very precise in terms of how you're asking the question. answering the question. Next, I'm going to jump behind the curtain. So we're going to move away from the end user perspective over to analytics. When you go to the analytics for this knowledge base, you're going to see a trend graph over time. You can specify the date ranges. You see some high-level metrics of the number of questions that have come in within that range. You can see some statistics on knowledge base access or the organic searches. And I can click through, and what you see is a pie chart and 4 buckets on top: excellent, strong, average, and weak. When I talked earlier about being able to draw a direct line between the needs and interests and questions that your target audience or your customers are asking and the quality and coverage of your content, we talked about using the strength of our answers as a proxy for your content quality and coverage. And that's what you're seeing here. So we strive to get the combination of the excellent and strong buckets to be 80% or greater. That implies that when a user comes in and asks a question, 80% or more, they're going to get a very strong answer to the question they're asking. And then you can see there are average and weak buckets. You see those same classifications on the left-hand side, and I can expand each of these. And what you're now seeing are the questions within the knowledge base that got hit by user queries. If I further expand under each of those questions, what you're now seeing are the questions that end users asked clustered under the knowledge base question that is semantically similar to the questions being asked. So in this case, we look at the knowledge base question: what is the process of opening a retirement account? Some people asked about the process of opening the account. Others asked about open a Roth or a rollover IRA, opening a rollover IRA, saving for retirement, or setting up an IRA. The benefit here is that with most search histories for token-based search, you're getting a cluttered list of disparate queries that you have to search through to try to really get a sense of what's top of mind for your target audience above all the noise. And it becomes pretty difficult to understand, what are the key things that are of interest or importance to your customers.
Actually, Mark, I'm going to jump in because we're going to run out of time here. There are a set of questions that are all related. We'll have time for this set of questions, and then we'll wrap it up. So, and I'll give this to Ryan. So, a bunch of questions go over the same thing, and there's 2 elements. One is LLMs are not trained on information behind the firewall or corporate data. So how do you contemplate that? And then the other element is that information that's behind the firewall is not, it's like acronyms and brand specific. It's not like natural language. So how do you deal with that?
Yeah, that's the design principle, or the problem that we were trying to solve behind the design principle with using the vector embeddings and the graph representation. Because you can get really good vectors on general English, but then once you get into the enterprise and you have this domain specific content, how do you then have it understand that domain specific content without having to go through this long, expensive, drawn out retraining or building from scratch process? And so being able to embed human curated knowledge, or actually encode that human curated knowledge into that graph, you can actually change the meaning of the vectors post vectorization and steer it in the direction of your organization. So a lot of organizations have thesauri, taxonomies, and other human curated knowledge that you can use to actually extend that language model to understand the domain specific content. And obviously we can get super deep on this in a follow-up conversation for whoever, asked those questions.
Well, very good. Well, thank you everyone for taking the time to attend our webinar today. All of you who attended or registered will get a link. Please feel free to share it with your colleagues. We would love the opportunity to talk to you directly and actually put together a little demo on your data to show you how quick and easy it is to make your data, which may be searchable today, but make it even much more searchable in weeks, not months or quarters. You can come to www.kyndi.com. You can also email us at info@kyndi.com, KYNDI. So thanks, everyone. We'll stop now and look forward to talking to you all in the future. Take care.
Thanks. Bye.